Welcome back to this second day of section 8.2. Today we are going to talk a little bit more about constructing and interpreting a confidence interval, so a little overlap with the first day. And we're going to learn how to determine the necessary sample size for a specific margin of error. And then finally, we're going to talk about how to use our calculators to help us calculate confidence intervals. So if you recall, we left off with this formula here for calculating a confidence interval, and we talked about the necessary conditions. So let's go back to those necessary conditions. In number 4, we're asked to remember that when constructing a confidence interval, you should make sure that you have checked the appropriate conditions. Explain why each of these conditions is important. So pause the video for a minute and think about the answer to those questions. So why do we take simple random samples? Because we need an unbiased representation of the population. Why do we need independence? We need independence so that we can use the formula for the standard error in our calculations. And why do we need normality? So we can use the properties of a normal distribution to calculate z-scores and find probabilities from there. So we're going to take a look at an example here. If you move on to the next part, we have the following question. Alcohol abuse has been described by college presidents as the #1 problem on campus, and it is an important cause of death in young adults. How common is it? A survey of 10,904 randomly selected U.S. college students collected information on drinking behavior and alcohol-related problems. The researchers defined frequent binge drinking as having 5 or more drinks in a row 3 or more times in the past 2 weeks. According to this definition, 2,486 students were classified as frequent binge drinkers. Identify the population and the parameter of interest. So I would like you to take a minute and pause the video and work through this entire problem. Part A, Part B, Part C, Part D, and then unpause the video and compare your answers to mine. So the population of interest in this scenario is U.S. college students, and the parameter that we're interested in, P, is the proportion that binge drink. So we're checking our conditions. Random sample. Make sure that when you check your conditions, you justify them. You don't just think through them in your head or write down something like random sample. Writing down something like random sample does not clarify whether or not you think the condition was met, you know the condition needs to be met, or it was actually met. So say things that are clear, like random sample is stated or was stated, which is the case in this scenario. The sample size is 10,904, and I think it's reasonably easily less than 10% of all U.S. college students. Our sample proportion, 2,486 out of 10,904. So if you take the sample size times the sample proportion, you get the number of, quote, successes, the number of students that binge drink in this case, and n times 1 minus p hat, quote, the number of failures, which is the rest of the sample, 8,418. Clearly, both are at least 10, so we meet all the necessary conditions, and we are going to proceed with our confidence interval. For a 99% confidence interval, the critical value is 2.58, and the calculations are as follows. We find our sample proportion as a decimal, plus or minus the critical value times the estimated standard deviation of the sampling distribution, and we get the following interval. And recall from section 8.1, this is how we interpret a confidence interval. In this case, I am 99% confident that between 21.76% and 23.84% of U.S. college students binge drink. Remember, we don't know for sure if that confidence interval contains the true population proportion. So it either does or it doesn't. Don't use probability in your interpretation, or the word probability in your interpretation of a confidence interval. If you would like a little more practice, you can pause the video here and work through this example. When you're ready to check your answers, you can unpause the video and move on. In this problem, it says to check all the conditions and show all your work. You should be doing that even if it doesn't say that. The only time you shouldn't worry about checking conditions or showing work is if you're told not to. So a random sample was stated in this problem. Our sample proportion is 246 out of 439. So the number of successes is 246. The number of failures is 193. Both are at least 10. 439, our sample size, is easily less than 10% of all U.S. teens. And next comes our calculation. Our sample proportion plus or minus our critical value times our standard error gives us a confidence interval that goes from 0.505 to 0.615, and then we end with an interpretation of that. I am 98% confident that anywhere from 50.5% to 61.5% of all U.S. teens believe smoking marijuana is harmful to their health. Clearly, vocabulary is a big part of this class, so I want to reiterate in the next problem what some of these values are that we found in this example. So the point estimate was our sample proportion of 0.56. The critical value was how many standard deviations in each direction we go with our confidence interval. The standard error is the estimated standard deviation of the sampling distribution found using this formula. And the margin of error is the combination of multiplying the critical value times the standard error. So the next thing we're going to do is we're going to talk about using our graphing calculator to do these problems. And just to be clear, I encourage you to use your graphing calculator, but you still need to show all your work. So your graphing calculator in this last problem, all it does for you is find this result for you without you having to punch in all those numbers on the home screen. So I'm going to go through and show you how to do this on your calculator. All right, so here we go with the calculator. So the first thing you need to do is take a look at your number, quote, number of successes, in this case 246, our sample size, and our level of confidence. When we go to the home screen of the calculator, hit the Stat button, go over to Tests, and there are a whole bunch of tests. And I know we haven't called these tests, we call them confidence intervals, but on the calculator, they consider them the same thing. So we are looking for something to construct a confidence interval. So you'll see number 7, Z interval, number 8, T interval, number 9, 2 sample, Z interval. We're going to keep going down until we find something that seems more appropriate for what we're doing. And when we get down to A, 1 prop Z int, so it's one proportion, we're constructing a confidence interval using a Z distribution. So select that one, and it brings you to here. So X is the number of successes, and if you recall, in our example, we had 246 successes. So we're going to put that in, 246. Our sample size was 439, so we're going to put that in, 439. And our level of confidence was 0.98. We're going to put that in. And that's all we have to do to get our calculator to calculate a one proportion confidence interval. And then you hit calculate. So there's our confidence interval. It goes from about 0.505 to about 0.615. And you can see that is what I got, which is how I actually did it in the first place. Now there's one thing I want to show you about using the graphing calculator to construct this confidence interval. You need to use the number of successes and not the proportion of successes. So when you select this, if we had known that 0.56 was the proportion of successes, you cannot put that in. It will not work. So here's what you could do instead. I know some of you aren't fans of mental math, but so here's a quick way to do this. Take that proportion and multiply it times the sample size, and do it right there. And that, if it comes up to be a number that's not a whole number, you're going to have to fix that. So what you do is you round to the closest whole number. So we had 245.84, which rounds to 246, which was our actual number of successes. So that's my advice on using the calculator. Please use it to do the calculations, but you still need to show all your work. We are going to wrap up this video by calculating the necessary sample size for a particular margin of error. So you may or may not have noticed this, but in many polls, the sample size is somewhere between 1,000 and 1,500 adults. So we're going to talk about why that is, but first we're going to figure out why we need a particular, how we calculate a particular sample size. So the formula for the margin of error for our confidence intervals are the critical value times the standard error p hat times 1 minus p hat all over the square root of n. So if you think about that, if you know what you want the margin of error to be, and you know what level of confidence you want, and you have some idea of what the sample proportion is, you can solve for the sample size. A word of advice: if you have no idea what the sample proportion is, use a sample proportion of 0.5, because that will give you the largest possible sample size necessary for your margin of error, and that is the most conservative approach. If, on the other hand, you have some idea what the sample proportion is, use that, because that will help reduce the sample size. So let's take a look at an example. A company has received complaints about its customer service. The managers intend to hire a consultant to carry out a survey of customers. Before contacting the consultant, the company president wants some idea of the sample size that she will be required to obtain. One critical question is the degree of satisfaction with the company's customer service measured on a 5-point scale. The president wants to estimate the proportion of customers who are satisfied, that is, who choose their either satisfied or very satisfied, the two highest levels on the 5-point scale. So, as typical with AP Stats free response questions and some multiple choice, there's a lot of information there, not all of it's necessary. In Part A, it says she decides she wants to estimate the estimate to be within 3% at the 95% level of confidence. How large of a sample is needed? So here's how you do this calculation. We know we want the margin of error to be 0.03. We know the critical value for a 95% confidence interval is 1.96, and we have no idea what the sample proportion is, so we're going to use 0.5 for that. And basically, we're going to solve for n. So, a little algebra skill here. So we want to isolate n. Here's my suggested way for solving for this. Take both sides and divide by 1.96, and you have isolated the square roots. So you've got 0.25 over n. Square both sides, and when you square the right-hand side, the radical goes away. So you end up with 0.03 over 1.96 squared equals 0.25 over n. My next step would be take the reciprocal of both sides. 1.96 over 0.03 squared is equal to n over 0.25. Now, all you have to do is multiply both sides by 0.25, and you have your value for n. Save all your rounding till the end, and very likely n is not going to be a whole number, so you always round up to be more conservative. In this problem, it turns out that the left-hand side is 1067.1 repeating, so our sample size that we should use would be rounded up to 1068. So, pause the video, do this same problem again, and try this with a 2% margin of error. Then unpause the video and check your answer. So in Part B, if you got a sample size of 2,401, congratulations, you are correct. If you would like a little more practice, pause the video and do the next check your understanding. In this case, we had some idea of what the sample proportion might be or is, So we would go with that in our calculation, and you can see that it significantly reduces the sample size. If we wanted to cut the margin of error in half, what are we going to have to do? We would go through the calculation and we get this answer of 2,732. And you will notice, or you might notice, that the sample size has to be 4 times larger to cut the margin of error in half. And that stems from the formula, which in the standard error we divide by the square root of the sample size, and the square root of 4 is 2. So if we multiply the sample size by 4, we're going to cut the margin of error in